Welcome. This is 5.1 Key Features of Parabolas. All right. So in our last unit, we talked all about solving quadratics. Okay. Whenever we solve those quadratics, really what we're trying to find was the x-intercepts. So now that we've learned how to solve quadratics, now we're going to graph them. So in order to graph and to understand what we're talking about, there's a lot of vocabulary. Okay, a lot of key features of parabolas that we need to talk about, and let's do that now. All right, so here's an example, a graph of a parabola. It's it's from a quadratic, so quadratics are always written something like this: y equals ax squared plus bx plus c. Okay, that is a standard form of a quadratic. And like I said, it has lots of key features, all right? So looking at this graph, we can look at y-intercepts. So y-intercept is the point where the graph crosses the y-axis, right? And that's labeled right here. So if we wanted to write that for our example, that would be 0, because we always do x comma y. So the x value for the y-intercept would be 0, and the y value would be -3. Okay, x-intercepts, those are the points where the graph crosses the x-axis. So looking at this, these are labeled here. One is at -1, 0, and the other is at 3, 0. Right, and so I like to make a point that we have a parenthesis for x-intercepts because sometimes there's 2, oftentimes there's 2, but there's also examples where we could have 1 intercept. So say this was our graph and we had a parabola, okay, where it crosses the x-axis at one single location. Okay, that would be the 1 x-intercept. And then we can also have parabolas where it never crosses the x-axis, something like that. Okay, and when we solved quadratics, those would be where we had imaginary x-intercepts, because you can see it doesn't cross the x-axis. Okay, and parabolas can also be downward facing. Okay, too. All right, so let's get more into this. So it says, and you may want to have your notes out while you're doing this because it's easier probably not to go back and forth looking at this. But axis of symmetry, so that's labeled on here too. Here they call it the line of symmetry, same thing. It is the vertical line, it's always vertical, that crosses the parabola in half. Okay, so parabolas are symmetric. Okay, so axis of symmetry in this situation would be x equals 1. All right, we need to always write it as x equals. If you just write 1, then it won't be a line. Okay, it would just be a value. Okay, so we need to write it as a vertical line or an equation, which would be x equals 1. All right, a vertex is the turning point of the parabola. So here we have slope is negative, 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 negative. Okay, then here at this point, the slope is 0, and then it starts being positive again. So it would be the turning point of the slope of the line, okay, or it's always just like this, like the lowest point of the parabola, or if it's concave down, it would be the highest point of the parabola. Okay, so in this situation, the vertex is 1, -4. Okay, and make sure that whenever we write ordered pairs, it's always in a parenthesis. So don't ever write it without a parenthesis. Okay, next it says max or min. So is that vertex a maximum or is it a minimum? Okay, so is it the lowest point or is it the highest point? Okay, so here it would be a minimum. In this situation, it would be a min. And what is its value? Okay, what's the lowest value? What is that minimum value would be -4. Okay, and then it says x value that maximizes, or in this case, the minimize. What is the x value that minimizes the function? What is the x value that corresponds to the minimum? Okay, in that situation would be 1. Okay, so if you plugged 1 in, it ends up giving you the lowest value, which would be -4. Okay? Oops, I erased that. Okay. Okay, so those are key features. And then we're going to also talk about intervals. So, like, domain is an interval. So these are, like, I try to have this separated. Okay? All of these parentheses that we've up here, those are just points. Okay, now we're going to be talking about intervals. We also use parentheses oftentimes, but we're not talking about points when we're talking about intervals. So domain is all possible x values of the parabola. So we scan from left to right. All right, so this parabola keeps going on forever, both directions, okay? So with quadratics, the domain it starts from -infinity way out here and ends up way over there to infinity. So domain, we always write it like this, -infinity to infinity. Okay, and this is like using the x-axis. Okay. Another way to write that is all real numbers. So if you ever have an interval that goes from -infinity to infinity, we can write it like this. R has a double line on the left side of it. Okay, so that's we talked about, and when we classified numbers, that would be real numbers, all real numbers. Okay. So, and then range is all possible y values. So we scan from the bottom to the top. So it's kind of hard for me to show you when you can't see my hand, but you start at the bottom, okay, keep coming up. This is my hand coming up. When it starts is when the range begins. So it starts at -4, and then it continues going all the way to infinity. So the lowest value is -4 and goes to infinity. So -4 to infinity. Okay? And that uses the y-axis. All right? Range is the only one that uses the y-axis. And range is also the only one, at least with quadratics. So keep in mind that this is just what we're talking about with quadratics. In Sec 3, things may be different. So range starts at -4, and that's included on this graph. So we would put a bracket. A bracket means that it includes the value. All right? Parentheses does not include that value. And we always do parentheses on infinities because infinities never end. Okay? It's not a value. Infinity is not a value. It's not something that you can end or start at. Okay? All right? And then increasing and decreasing. So increasing, I like to think of this as you're like going on a walk, okay? And you're going left to right. Okay? As you go this direction, you are decreasing. The elevation is decreasing up until you get to the vertex. When you get to the vertex, you continue walking, but you're going up. So it's increasing. So decreasing in this situation starts at -infinity all the way to the vertex, which would be 1. So -infinity to 1. And, oh, sorry, I had that backwards. That was decreasing. I put it in the wrong spot. So decreasing is -infinity to 1. And then it increases as you walk up. Change the color. So from this point on, here you are increasing. So 1 to infinity. Okay, didn't write that very well. Let me try it one more time. 1 to infinity. Okay? And you may say, Mr. Warner, why do we do a parenthesis for 1 instead of a bracket? Okay, so as you go this direction, you are decreasing, your values are decreasing, your y values are decreasing up until this point. Okay, it's at that point of the vertex, it's not increasing or decreasing, so we don't include that point. Another way to kind of think about that, let me try and clear this up a little bit. Another way to think of this is decreasing is negative slope. So at this point, your slope's negative, 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 but then at the vertex, the slope is 0, and then we have increasing was positive slope. Okay? Sorry, excuse me. So we don't include that point because the slope's not positive or negative. So that's just another way to think of increasing or decreasing. Okay, if that helps. Increasing would be negative slope, and decreasing, reverse that. Sorry, I'm trying to get this done before I go home for the weekend. So increasing is positive slope, decreasing is negative slope. Okay? And then we've got direction of opening. Okay, so happy parabola is concave up. You're thinking up. If a sad parabola is concave down. So in this situation, it's a smiley, happy parabola, so it's up. Okay, oftentimes we will write it as concave up. Okay, all right, and it says, note all intervals except the range are done according to the x-axis. Okay, so as you notice, when we did it, this is x-axis, this is x-axis, okay? Another thing I should introduce, although you will probably see it more the way that we just wrote it, but another way to write these is called inequality notation, where you use less thans, greater thans, less than and equal to, greater than or equal to, kind of thing. So domain, in this situation, if we did inequalities, okay, this would still be R. You could just write it like that, okay? Or you could do all x values less than negative infinity all the way to positive infinity. So that would be inequality notation. Range, range would be, if we look at this, sometimes I don't like to look at the interval notation when we want to do it. I just like to look at the graph. So if I want to find the range, is we want all y values greater than negative 4. So all y values greater than or equal to negative 4. Increasing, I like to use my hand on the while we're doing it in class, but let me just clear this up a little bit. So if we want to find where it is increasing, so it's increasing all x values greater than 1. All x values greater than 1. Okay, and then it's decreasing the slope, or as you walk on this line, this direction, it is decreasing everywhere that direction. So all x values less than 1. Okay? All right. So let's do some examples. And there's these other 3 that we'll talk about why we go on. Okay? So here was a graph. Here's a what? Okay, here's a graph. We'd want to label these. So x-intercept. Okay, so here we have 2 of them. One's at negative 2, 0. The other is at 4, 0. Y-intercept is 8, 0. Axis is symmetry. I'll draw a little line of that. Okay, again, it's a line, so we need to write it as x equals. And in this situation, it's x equals 1. The vertex, right here, vertex. It's the turning point. So we'd write that as 1, 9. Okay, is the vertex a maximum or a minimum? Here it's a maximum, and its value would be 9. Domain is all real numbers. Range, okay, we start at the lowest, so it would start, this is it, all the way to negative infinity. So it would start at negative infinity, and it would end at the vertex, at that y value. So again, range is always using the y-axis. So it starts at negative infinity all the way up till 9. And we would want to make it as a bracket because that value is included on the parabola. Okay? All right. Okay, next we have increasing. So increasing, if you're walking on this mountain and you're going left to right, it's increasing all the way until you get to the vertex, which is the highest point in this situation. So it would start at negative infinity as increasing all the way to 1. And then it would decrease from 1 to infinity. Direction of opening here would be down, concave, down. Okay. And then positive, negative, and end behavior. All right, so we didn't talk about these before. I'm just going to erase this for a second. Okay, so positive. When we're talking about positive, where is it positive? We're really talking about why is there positive y's. We want to find positive y's. So positive y's would be in between these two areas. So these are all positive y's. Okay, so our interval would go from -2 to 4. Okay, that would be our interval for positive y values. Okay, if we want to find negative values, well, that would be all of these all the way to infinity. Okay, so we would want to write those intervals, that's where they start and where they end. So negative values, here if we start at the left side, it would be negative starting at negative infinity and goes all the way to -2. And then it would start again at 4 all the way to infinity. Okay? Because all of these are all negative values, and they would continue to go all the way to infinities. Okay? And then end behavior. Let me clear this out again. End behavior. Okay, so if this continues to go forever, and it does, okay, we want to find what happens as you go in positive x direction all the way to infinity. Okay, so as long as you keep going this way, if you plugged in 8 and then you plug 9, okay, as we keep going, we want to see what happens to y. Okay, in this situation, this keeps continuing all the way to negative infinity. But as you go this direction, as x goes to the other side, to negative infinity, y also, again, goes to negative infinity. So this part, all of this, what I boxed, is going to be the same. We just want to see what happens when x goes to infinity, what happens to y. Okay, and when x goes to a negative infinity, what happens to y. Okay, so when it's concave down, as this is, your y's will always go to negative infinity. If we do a situation where it goes concave up, okay, in this situation would do x goes to infinity, y, in this situation goes to positive infinity. Okay, and they'll always, with quadratics, these will always, the y's will either both go to positive infinity or they'll both go to negative infinity. Okay? In other words, y goes down, or in this situation, y goes up to infinity. All right, so we'll probably just do a couple more examples. If you feel like you're good with it, let's go, at least make sure you follow this. Let's do the positive and negative for this situation, okay? So positive values, in this situation, positive is everything that direction and everything this direction. So these are all positive values. So positive would start at negative infinity to negative 1, and from 3 to infinity. Negative would be all of this part. Okay, so that would start at negative 1. I guess you could even put it right here, negative 1, 2, 3. Okay. So you're going to be using the same, they're actually your x-intercepts, okay, those values, but, that's what you're going to be using. Okay. I need a drink. All right. Sorry, that was probably loud. Okay, so I'm just going to go ahead and do some more. If you would, pause, please, and see what you get. Some of these are a little different, so you may want to follow through. There's 2 more. Okay? Oh, yeah, and I also didn't talk about, we can also write the positive and negative as inequalities. So like this one, if you did it positive, it'd be all x values less than 4 and greater than negative 2. Okay, so we could write that as positive y values. And then from negative infinity to negative 2, this would be everything, all x values less than negative 2, and this would be all x values greater than 4. Okay? Or this one, you could write it, still you could do this one as all x values between negative 1 and 3. And you could write this as all x values less than negative 1 and all x values greater than 3. All right, okay, but I just want you to be aware of that. On the homework, you need to do both, but then after that, you can just all do it either way you'd like. Okay, so I'm just going to go through these ones fairly quick. All right, here we have our x-intercept. We don't have any, NA, not applicable, doesn't cross the x-axis. Y-intercept looks like it's maybe like 0, negative 2.5. Axis of symmetry, x equals negative 1. Vertex, negative 1, 2. Max or min, it's a max, and its value is negative 2. Domain is all real numbers. Range starts at negative infinity and goes up to negative 2 would be the highest value. Make sure you put it as a bracket. Range is the only one that uses the y-axis, and the only one that uses a square bracket in this situation. Increasing, so you're walking on your mountain, okay, it's increasing all the way to here. So it would start at negative infinity, goes to negative 1, and then decreases from negative 1 to infinity. Direction of opening would be concave down. Positive, okay, it's never positive, doesn't apply this situation, and negative would be all real numbers. You could say it from negative infinity to infinity. And behavior is x goes to infinity. In this situation, y goes to negative infinity. And as x goes to negative infinity, y goes to negative infinity. So both of these areas concave down, so it goes to negative infinity. Okay, here's a concave up. So x-intercept, here we have 1. X-intercept would be negative 2, 0. Y-intercept would be 0, 4. Axis of symmetry is x equals negative 2. Vertex is, negative 2, 0. Right, here's your vertex. it's a minimum, and its value is 0, okay? A lot of people, just remember, I guess this is also y, okay? You want to write it as y. It's a minimum, the smallest value here would be 0. And in the class, a lot of people wrote -2. So be aware of that. Say range is all real numbers, or sorry, domain. I put it in domain, didn't say it right. Okay, range starts at negative, starts at 0, and goes all the way to infinity. Okay. I mean, there's lots of things that you can kind of see, like these relationships, like the minimum value is one of your values in your range, and you'll see some of the x-intercept stuff will be in other stuff. Anyway, so it's a lot of these numbers you write the same things. It's just we're just putting them in different locations. So increasing, okay, you're walking up the mountain, so it starts at -2 and goes to infinity. And decreasing is from -infinity to -2. Direction of opening is concave up. Positive, it's positive. This is another thing that's a little tricky. It's positive everywhere except for the vertex. Vertex is at 0. So we'd want to write it in 2 parts. So it would start at -infinity, would be positive all the way until you get to -2. And then, but it would not include -2, so we'd have to write another from -2 to infinity. Negative is NA, doesn't apply. And end behavior as x goes to infinity, y goes to infinity for both of them. So as x goes to -infinity, these both go up to positive infinity. Okay? Well, if you have any questions, please let me know. I know some of these are a little tricky, especially when you have lots of them, and some of them are a little different, okay? Just remember, positive is just things that are above the x-axis. Negative is everything below. So we just want the range where those lines are. And increasing, decreasing, it's just like you're walking from left to right, where you're going up or where you're going down. Okay? All right, we'll see you.